So continuing on with Unit 1, let's talk about an idea that we did fairly in-depth in Algebra 2. I just want to refresh it. It's the idea of function composition. Okay, so I'm going to give three functions that we can work with here. F of x is going to be the function negative x plus 2. G of x is going to be the function 2x squared. And h of x, I'm going to give you the table for h of x with these values. Negative 3, negative 4, negative 2, negative 2, negative 1, 0, 0, 2, 1, 4, 2, 6. And h of x, this is only a partial table for h of x. H of x has a domain of negative infinity to infinity, and it is linear. So that's only a partial table. So, for example, since the domain is negative infinity to infinity, I could plug in 0.5 for x and get an output that's a real number. It's just that that's not listed on the table. So I'm only seeing some of the possible inputs for h of x. Okay, so let's start off doing a couple numerical examples just to refresh us. So first, let's start off with the basic idea of just refreshing function notation. So if I wanted to evaluate f of 7, that means that 7 is the x value. I'm going to plug 7 into x, and I want to know what the y value is. So f of 7 is going to equal the y value. It is the y value that you get when you plug 7 into the equation. So when you plug in, make sure you use parentheses. So it's negative parentheses 7, close the parentheses, plus 2. So that gives me a negative 5. So that means that 7 is the x value, negative 5 is the y value. So 7 comma negative 5 would be a point on the graph of f of x. Okay, so that's just a quick refresher of some function notation, plugging in, evaluating, some of those ideas that I'm sure you're very comfortable with already. So let's say I wanted to do something like this. Let's say I wanted to do g of f of 7. And I wanted to evaluate that. So the directions, I should probably write the directions here. The directions would just say evaluate the expression. So that just means we're going to take what we're given and simplify, get an answer. Okay, so I want to evaluate g of f of 7. Now I want to kind of read this from the inside out. This means I'm going to plug 7 into the function f of x, get an output, take that output, and then plug that into g of x. So now, notice I already know what I get when I plug in 7 at f of x. I get negative 5. So I'm going to take that negative 5 and plug that into g of x. So this would give me 2 parentheses negative 5 squared. So I got to do order of operations here. I'd square, I'd take care of my exponents before I multiply. So this would be 2 times 25, which is 50. Okay. So just remember, composition, you're working from the inside out. So now I could do the same, I kind of take care of the same strategy, but I could work this out algebraically using a variable expression, an expression with variables in it, rather than just doing this numerically. So I could ask to simplify this, f of g of x. So that literally means that we're going to take the function g of x and plug it into f of x. Now, what does that mean? That means that everywhere we see an x, in the function f of x, we're going to replace that x with whatever g of x is. So that sounds a little confusing. So let me write it out this way. That's just Miss Crass having a sneezing fit in the background, if you can hear that. Bless you, Miss Crass. She made it. She's living. So it's fine. Don't worry about it. So I'm going to write f of x. F of x is negative x plus 2. Now notice what I'm doing here. I'm leaving a big space where the x was. Now in that space, I'm going to write down exactly what g of x is, which is 2x squared. So notice, I'll say that again. I'm writing f of x, but I'm putting parentheses, and I'm leaving a big space where the x would be. And then within that space, I write down what g of x is. And I do that for all of the x's in f of x. Now I just simplify that, and that would give me negative 2x squared plus 2. So that right there, that is f of g of x. So when you compose functions with functions, algebraically, and you're doing this not numerically, so we've got some variables in there, you're creating new functions. So f of g of x is a new function, negative 2x squared plus 2. Now, if I switch the order around here, if I did g of f of x, I would not necessarily get the same answer. So composing functions is not, it's an operation that is different from addition in the sense that if I add two numbers, like for example 2 plus 3, that gives me 5. Well, if I added 3 plus 2, if I just switched the order of the addition, I would get the same answer. That's not true with function composition in general. So if I compute f of g of x, what that function is, that's not necessarily going to be the same as g of f of x. So I'm plugging f of x into g of x, so I'm going to write down the formula for g of x, 2x squared, but notice where there's an x, I'm leaving a huge space, and then within that space I'm going to write down what f of x is, which is negative x plus 2. And now I'm just going to simplify that. Again, got to watch out for my order of operations here. I need to square the binomial expression negative x plus 2. So really, before I multiply, distribute through the 2. So really what I'm doing here is negative x plus 2. I'm squaring it, so that's negative x plus 2 times negative x plus 2. And then however you're comfortable with expanding out that binomial multiplication, if FOIL, if you like that expression, or using the box method, however you're comfortable of doing it, just do it that way. So if we did that, we'd get 2 times x squared minus 4x plus 4. And then if we distribute through the 2, we're going to find that g of f of x equals 2x squared minus 8x plus 8. Excellent. So now let's get an example in here numerically that uses that table. How about we figure out what's f of h negative 3. Now, in this case, I'm plugging negative 3 into the function h, but now there's no formula to plug in here. I just have a table. Well, I can still do my plugging in with the table, because think about it, negative 3 is my x value, so I want to know what y value pairs up with that for my function h of x. So I just look up at the table. If negative 3 is the x value, then the output, the y value, is negative 4. So that means I'm going to take that and plug that into my function f, and I will get 6. So one final example. What if I did h of g of negative 1? Okay, so that means I'm going to plug negative 1 into g. I'm going to do that work just kind of right underneath here. That's 2 times negative 1 squared, which is 2. So I'm going to take that 2 and plug that into the h. Now again, there's no equation here, so I just got to read off the table. So x is 2. What's the y value? It's going to be 6. So hopefully that was